Hi, it's Jan Beta, and we're still in the month of Tandy, unless you lost the concept of time completely, which happens these days. And Tandy means there's still a bunch of YouTubers all around the world and bloggers and forum posts dedicated to the Tandy Radio Shack machines. And actually, I am dedicating a bunch of videos to the TRS-80 Model 1 that you can see on the bench here. Yeah, it is still on the bench, so I haven't quite fixed it yet. So this is going to be part one of a series of repair videos, hopefully repair. And yeah, there are quite some issues. First of all, I have to thank everybody who commented on my power supply build in the last video, which was far from perfect, obviously. Made a bunch of mistakes. First of all, used double-sided perf board, which I addressed a couple of times during making the video, and that was not the brightest idea. In the meantime, I have refined the power supply quite a bit and dremeled away some of the little contacts and made gaps so we won't get any arcing or any dangerous behavior from the power supply, probably. So I pretty much replicated exactly what the schematics told me to do that I linked in the last video. I'm going to link them in below again. So maybe if you want to build your own, do some research and maybe take some more precautions than I did, and don't use double-sided perf board. So today is going to be TRS-80 troubleshooting galore. And there's quite a few issues I managed to fix. There are more issues, but I had to order parts and I wanted to get this video out. So, yeah. One of the mistakes I made was very embarrassing, but you are going to see. So let's dig into the bowels of the TRS-80 again. The first thing I actually want to do, because this thing should start up without the keyboard, and yeah, just moving this around, I think already delaminated this ancient flat flex cable, so to an extent. I measured this actually and it did work when I first measured it for the last video, but I think I just want to cut this for now so I can handle the board better. And this machine should start up without the keyboard, although the keyboard is needed to actually make the machine work, but it should at least have a startup screen and things like that without the keyboard connected. So here's what I'm going to do, although it hurts quite a bit with an ancient machine like this. But yeah, there's no way we can save this and make this work reliably for any longer. So I'm just cutting it. Let me take a couple of seconds to thank my sponsor for this episode, which is Skillshare. Skillshare is a platform that offers videos on a variety of topics, all pretty much focused on creative work, and they offer curated content on just about anything that you would need, be it photography, be it video editing, be it audio editing. I've also used it to brush up on my electronics skills, which admittedly doesn't hurt, obviously. And yeah, it's just an excellent way of learning new skills without interference by ads or anything like that. And for a limited time, you can use the link in my description to get a free trial of Skillshare Premium membership, which gets you access to all the classes on there. So I recommend checking it out. So here we are. This is much better actually. And as we've seen in the last video, the problem with this, or at least one of the problems with this, is that I'm getting the main supply voltages, which are plus 5 volts and 12 volts, but I'm getting a slightly too high voltage on the -5 rail, like about -3.7 volts or thereabouts. And that's basically not enough to power up the system, I think. I think that's what's happened here. So I'm going to start with troubleshooting the power supply section, which basically is the lower region from this point of view on the circuit board here. So the power supply I made, which I think should provide the correct voltages for this machine. I'm still not 100% sure because it's a self-made thing, and although I refined it a bit, I'm still not 100% certain, but let's say 90% certain that it should provide the correct voltages for this onboard power supply section to provide the rest of the board with the correct voltages in theory. So what happens on board, which is rather sophisticated really, is that we have a full bridge rectifier, which is this green thing here, that takes the AC from the power supply and provides this section here, which basically is a very simple power supply built around a xenodiode, which is this one here, behind this capacitor. And that is a 5.1 volts Zener that is fed by the negative part of the full bridge rectifier, goes to that and should provide the -5 volts for the RAM mostly, because the RAM is what needs -5, +12 and +5. And the other part goes to this section of the board where there's two voltage regulators actually. These are 732 voltage regulators. One of them is responsible for deriving the 5 volts rail, which is then powered by this large transistor here. Yeah, the voltage is provided by one of the Z1 and Z2. And the 12 volt rail actually is basically coming from the DC the power supply provides, and is also regulated by a 723 regulator on board here. These 732 voltage regulators basically are variable voltage output, and you can dial in the voltages with these variable resistors here for both rails, and they are relatively spot on. I'm however not going to show you the voltages again. I did that in the last video. If you haven't watched that, maybe watch the last part of the last video. I'm not turning this on for now because the RAM chips, these are 4116 RAM chips, they react very sensitive to one of the voltages being out. And as the -5 volts is not spot on in this one, yeah, I'm not going to turn this on until I have done some further work on this. First thing I want to try, and that makes sense because I don't want to damage these 4116 RAM chips if they are still alright, which I kind of, they are very, very sensitive to all kinds of things, including ESD. That's why I'm wearing my ESD wrist strap again. And these basically die very quickly if they get overvoltage or undervoltage or electrostatical discharge, which I'm trying to prevent by using this. What I'm going to do before working on this any further and before powering this up one more time is to remove all the 4116 RAM chips, because if one of those is shorted, chances are that they are messing with the voltages, so they are actually pulling the negative voltage high in this case. That might very well be the case here. So that's my first suspects are the 4116 RAM chips, because they are prone to failure, as I've learned in former projects, and yeah, also that's like common knowledge for retro computer enthusiasts, I guess. So I'm just going to pull all these chips. They are all socketed, which I believe they have been replaced at some point. I can't see any date codes on these NEC chips, but the fact that they are all socketed might hint to them having been replaced at some point. I'm actually using my smaller chip puller here. Yeah, these sockets seem to be original sockets. They are the same sockets used everywhere else on the board. So maybe this was just a machine where the RAM chips were socketed from factory. There we go. Okay. Got all the RAM chips removed. Also printed out the whole technical manual because it's just so amazing, because you learn so much about the computer, and it's a pretty good read actually. That's really cool. If you want to learn about old computers, I'm going to link this in the description again. This is really highly recommended reading for anybody working on any old computer, really. So I'm powering this on again. And checking for the voltages. Let's see if this helped any. No, this is still my negative voltage, it's still out. So this is my 5 volts, which is at 5.03 volts. This should be my 12, which is at 12.09, which is fine. This should be my negative voltage, I think. And it's at minus 3.7 as before. Yeah, it's 3.5 at the Zener diode too. I don't know if you can see that. Yeah, there should be spot on minus 5 after the Zener diode. And there isn't. That's bad. So something else is broken, I guess. The RAM, if one of the RAM chips was shorting, you would probably get wonky voltages on one of the rails. So that was a good first thing to try, I guess, because they are socketed. Okay, let's dig deeper. So I want to measure the voltage right after it comes in here, I guess. And there's some botch-wise. I already cut this one. I have to undo some of the mods that have been done to this board. That's, I guess, the next step, because some of them might be wonky or not executed right. So just turning this on again. Okay, so our AC voltage should come in here. And that's 16 point something volts AC, which is actually good. That goes to our voltage regulator. And it's still at 16 volts AC, that's good. So our power supply seems to work. Then it gets rectified. Oh, we get 18 volts DC. Okay, so that's good actually. So that's our rectified voltage, which is, yeah, according to spec, that's what's to be expected. So the thing is that we don't get a proper voltage at our Zener diode. So yeah, that's minus 3.49. That's too little. So yeah, it might just be a bad Zener diode. So what we checked so far, we checked that our voltage is actually getting to the board, our AC, which is the one we're looking at because the minus 5 volts rail is not working correctly. And now we have to look at the filter capacitors in this area, because they are filtering the rectified voltage. And we are going to have to look at the Zener diode, because that's what actually provides the voltage to the rest of the board and what determines the voltage. Let's just recap the whole board, I guess. And I think I want to remove the capacitors in this area. And there's one other capacitor over here, electrolytic capacitor, that I just want to recap that too. And there's another one all the way to the left. So let's just replace the electrolytic capacitors and see if that changes anything. Yeah, in this circuit also, people were asking why I need the 2 transformers and the power supply. Yeah, the original power supply actually has only 1 transformer with different output windings. And you basically need a center tap, because the center tap is the ground level, which then provides the positive side of the 5 volt rail and the negative side of the 5 volt rail. So you need a center ground basically to go for the AC voltage to work in this circuit. And that's how this is achieved here. So the negative side is used for the negative voltage, and the positive side is used for the positive voltage. So first of all, I'm removing this watch wire, which is connected to the video output, to pin 3 on the video output, which isn't actually connected, but it takes the video signal from the chip that is actually mixing the video signals, the sync signals together. That's provided to pin 3. So there might be something wonky with that video output too. But we're focusing now on the power rail at first. That is not working correctly. So yeah, we're going to look into the video issue later. I'm just going to replace the capacitors now for this. It's something I regularly do, so replacing capacitors is not really a new thing for this channel. I'm also going to resolder some of the joints on the voltage regulators here, because frankly they don't look very good. So that's most of the board recapped. There are some more capacitors on this little level 2 ROM board, which are not so easy to get off because this is glued on, as I said in the previous video, with some nasty sticky foam stuff. So yeah, I'm just going to leave them as is for now for troubleshooting, and I'm going to see if this did anything. I'm not going to replace the big ones here. I measured the ESR and the capacitance on those with my little ESR meter, and they are alright. The ones in this area are for the -5 filtering, so we are going to see if that helped any. No, we still got -3.6 or something volts. Next up, I want to replace the little Zener diode there, which might be the cause of our problem. And yeah, as I said, this is just the regular 5.1 volts Zener diode, which I have a couple of spare. So let's just see where it is. Yeah, let's replace it right away. So here's the circuit in close-up. That's the Zener we just replaced. Don't know if you can see that very well with all the reflections from the light, but you just have to trust me on this one. Okay, let's see if we get our voltages now. No. Let's poke around some more, I guess. So I think I found another issue. This is our rectifier here, and we should have our AC voltage coming in at the middle 2 pins. These 4 pins are our rectifier. Middle 2 pins are the AC voltage coming in actually from the socket here, which seems to work fine through the switch here. And then we have our DC voltage, which should be like 11 volts according to the technical manual, but something above 10 volts on both sides. And the negative side is already minus 3.6 at this stage, so that's not enough. Yeah, so that's the part that is used to derive the negative voltage from, and that's not high enough. So maybe we might even have a broken rectifier. So this is one of the diodes This is the other diode. This is the forward voltage for the diodes in the rectifier. So here's the section in the technical manual concerned the -5 volt supply. Source voltage for the -5 volt supply comes from the negative terminal of rectifier CR8. When switch S1 is closed, the negative DC is filtered by C1 and about -11 volts is applied to resistor R19. R19 is used to limit current for Zener regulator CR2, 5.1 volt device. The -5 circuit is about as simple power supply as can be designed. C4 and C3 is the 5 volt supply filtering, -5 volt supply filtering and noise suppressing caps, while C16 through C19 perform the transit suppression function. So it might be that C16 through C19 are shorting out something. Maybe our R19 current limiting resistor is broken, or our rectifier is broken. Or, of course, it might be something further down the chain still that's shorting or something like that. Let's check that. So the rectifier, according to the diode test I did, seems fine actually. Might still be an issue with the ground, but then the other side of the regulator. So here's C16, 17, 18, 19. We're just going to see if any of those is shorted to ground or something like that. R19, the current limiting resistor, is at 225 ohms and should be 220, so that's perfectly alright. Yeah, and it's also connected to our diode. So I think what I want to do is to replace the rectifier. So I'm using this BY164 bridge rectifier that I had lying around from another project, I guess. And it fits perfectly, so it should be powerful enough, or more than powerful enough, to actually provide the necessary oomph to the system. And it would be really embarrassing if this is due to my power supply in the end. By the way, I had to widen the through holes a bit. I'm just using this pokey thing. So let's see if we have any shorts, which wouldn't be fun. No shorts. It's also in the correct polarity, so the positive should go this way. No, it's a tiny bit higher, it seems. No, it's not really. So I actually found a burned component here, which is the resistor that's completely turned into coal. So maybe that one measures about 200 ohms still. Maybe that's causing trouble. I don't know. There doesn't seem to be a designator, like a marking for that resistor. According to the schematics, it's probably the resistor going from pin 4 of the cassette port, which it comes from, to ground. And that would be R67, which would be a 100 ohms resistor. So I'm just going to desolder that and replace it with a 100 ohms resistor, I guess. And see if that helps, maybe. So it seems our little piece of coal was R70, it says underneath. So yeah, I'm going to have to look that up in the manual, because that thing is severely gone and can't really make out any markings anymore because it literally turned into a piece of coal. So I found another burned one, this one on the back side of the board, and that measures around 220 ohms, and according to the markings that I can make out, which could be red, brown being a bit scorched, this could be a 220 ohms resistor actually. So I think I want to remove both of these resistors. And guess what? The R70 is not in the schematics. Of course. So I don't really know what that should be. That's the tape port. That shouldn't be of much interest to us at the moment. No idea why that was burned actually. Probably somebody experimented with this quite a bit. Yeah, also considering the other mods that have been done to this. So here's our cassette port in the schematics. And we are looking at pin 4. These diodes are actually okay. I measured those. CR10, CR9. And pin 4 goes in the schematics at least. It goes all the way over here, and then it goes over here. Cassette in. And then it goes to R67, which goes to ground, which is, I think, what we should be looking at, this 100 ohms resistor. And R70 just doesn't exist in the manual, so I don't know. That's confusing to say the least. But yeah, let's just try what this machine does without any resistor there, because that's just connected to the tape port. It should be fine without it. Okay, let's see what our negative voltage does. It's still the same. Of course, obviously this doesn't affect anything at all. For now I'm just going to put a 100 ohms resistor in there, because that's what's supposed to be there, according to the schematics at least. Okay, 100 ohms resistor to ground from the cassette in. So many issues here. So this is the part where it gets a bit embarrassing. After measuring around on the board, and I couldn't figure out why I wasn't getting the -5 rail right, I took a look at my self-made power supply, which I should have done in the first place, and it took quite some looks into this. And yeah, as I explained in great length, the transformer for the AC is supposed to have a center tap that's connected to the connector, to the output that's going into here. And that's used for getting one part of the rectified voltage for the +5 and one part for the -5. And the thing is that somewhere along the way, the connection to the center tap actually didn't make connection. So we didn't have a center tap, so our ground reference was off. So we had the 5-volt rail worked no problems whatsoever, and the -5 didn't get a proper reference to ground. The rectifier didn't get a proper reference to ground, so we didn't have the -5. And it's all my fault actually. So yeah, look, just turning this on again. I restarted the connection, and now what we have on our diode here should be -5.17, which is absolutely, utterly fine. So we have our voltages now. I'm going to recheck the other rails, but yeah, it was all my fault. So, okay, the board is powered up. Let me recheck the voltages here. Let me show you. This is just our missing center tap, and that's the one thing. You measure the output voltages from the transformers and everything's fine actually. But yeah, now we should have our 12 volts and our 5 volts, and we should have our -5. Yes, we have all the voltages. And yeah, I have to apologize for this. It's all my fault actually, because I didn't wire up the power supply correctly. Ooh, that hurts. Sorry. But yeah, I take it as it's kind of a relief and a lesson. Always suspect the stuff you did first. Whenever you're working on something, yeah. should have taken that into account, that my own stupidity in this case caused this fault. So now we have our power supply working. Both my power supply and the power supply on the board should be working perfectly fine now. It didn't hurt to replace the components I replaced, because those are components that are prone to failure, especially if they are like 42 years old, like in this case. But whoa, okay. And also good thing I took a closer look at the board, finding the burned resistors there. That didn't hurt either, but wow. Sorry. Kind of, I feel embarrassed and relieved at the same time at the moment. Yeah. Let's see if we get any output from this board after I put the RAM chips back in, I guess. And these RAM chips are probably fine. These are NEC, and these are, I think, much younger than the machine itself. Usually pretty reliable stuff. Yeah. Welcome to the land of young beta. We have fun and games. Lots of games. Lots of fun. Okay, now let's see if we get any output from this after the fix. Hey, and we don't get anything at all. No signal at all. Okay. Okay, before I start troubleshooting this, I'm just going to desolder the keyboard connector, because it's pretty delaminated now from handling the board, and I'm a bit afraid that things might short out. Yeah, this is rather inconveniently soldered on from both sides, so it's gonna take some effort here. So that came off rather nicely in the end. Bit difficult to desolder because there's solder on the top side and the bottom side of the board. So there at least seems to be some kind of improvement. If I turn this on now, actually there is a picture, but it fades out immediately. So we have a problem with our video output. Yeah, let me break out the oscilloscope and actually troubleshoot the video out. So I hooked up the scope, and I actually soldered on a wire to connect the ground connection permanently to the scope to make things easier. Yeah, first of all, let's check some basics on the Z80 or Z80, depending on where you are, processor, because that's the main thing in the system, the main reference for everything. Basically, all the address lines are on here, and the system clock actually is on here. And I have my scope set to DC, yeah, and 2 volts per division, so we should have nice signals for everything basically. Let's see. Okay, we have our CPU upside down basically, so we are going to probe pin 6, which should be 1, 2, 3, 4, 5, 6. Should be this one, and we should have our clock, which looks reasonable enough. There's a bit of noise on there, but I guess that's okay. And yeah, let's check some address lines. Actually got quite some activity going on there. That's address line 11, address line 12, address line 13, address line 14, address line 15. There's nothing on address line 15, okay. Address line 10, address line 9, address line 8, address line 7, address line 6, that looks sane, 5, 4, 3, 2, 1, 0. Oh, that's actually 0. I skipped one. Okay, so this should be ground, which it is. This should be refresh. M1. Reset. These are the data lines. There's quite some activity going on there. This is our +5 supply. Data line 6. Data line 5. Okay. Data line 3. Data line 4. That looks actually like a healthy processor. I don't know if address line 15 might just not be used or used for some special purpose. Just making a little mark there. Reset is active low, as you can see by the little line written on top there. So that's supposed to be high when it's not active. The system seems to be running according to the readings on the CPU, which is a good thing, obviously. Okay, let's take a look at the video sync stuff. There's actually this service manual is actually really good. They go into detail in great length here, so that's excellent. Z6 is used to generate the horizontal pulse. Z57 is used to generate the vertical pulse signal. Yeah, there's 2 potentiometers here that control the vertical and horizontal sync. If we are lucky, it's only those that are out. So yeah, let's compare the signals we get from the pins with our diagrams in the service manual here. Z5 pin 3. 1, 2, 3. We have a signal there. Yeah, we have something that resembles the signal we're supposed to see, I guess. Z5 pin 11. Okay, that looks good for a change. Z5 pin 6. 1, 2, 3, 4, 5, 6. That also looks good. We have a signal there. Z5 pin 8. 1, 2, 3, 4, 5, 6, 7, 8. That also looks good. Okay. Z6, 4, 5, 6. Yeah, that's a signal. That's the signal we're supposed to get. Okay, horizontal sync is there. Z57. Yeah, that actually is also good. I think I miscounted the pins there. So we have our video sync is actually there. So our composite video signal is actually supposed to come from Q1, which is this little from the emitter of Q1, and go directly to pin 4 on the video out. Maybe should see a composite signal there. Emitter of Q1. So this should be a composite signal. Yeah, that kind of looks like a composite signal to me. Let's see if we also get it on the actual connector here. Yeah, same thing. Okay, so we have some kind of video output there. So maybe it's just a matter of adjusting our little potentiometers. I think I just want to try, let's just mark the positions of these little potentiometers here. So we can take them back to where they were in doubt. Yeah, something's happening there on screen. So there we have a white screen. Yeah, there's some kind of signal. Well, there's definitely sync, because if we turn this off, it loses sync after a while. So, yeah, as we've seen on the scope, there is something happening on the output there. So here's another issue that might be causing the system to not fully work. This Z71 is supposed to be a jumper. So I also found this Z71, which supposedly is, as mentioned in the service manual, a dip shunt. So it's like a little jumper block, really. Originally there is like a socket with connections in there that you can cut according to how much RAM the machine should use. And according to the manual, in a 16K system, 4 to 13 are opened, which should be this. 3 and 14 are shorted. So 3 and 14 is this. And 4 and 13 are opened. But the other pins, I think, should all be connected. I made something like this, which is a replacement for the original socket that should be in there originally. So I'm just going to insert this and open the lines that should be opened according to the manual. Okay, testing. Oh, and look at that. We actually briefly got a picture there. A scrambled screen, which is kind of to be expected. Colorful. There's something wrong still with the video out. But we got something there. But it's really faint, so maybe there's something wrong with our video output circuitry still. So the other mod that has been done to the system, and I think just has been cut off at one end, is this piggybacked, this is actually video RAM, this is an SRAM chip, I think, to provide another bit for the system to actually address lowercase characters. So this is like a very common mod done to these, and it ends in these loose wires. And there are traces cut, and there's a piggybacked RAM chip, as I said, and there are traces coming from the RAM chip going to the board. So I need to research that before I can do any work on that. For now, I just left it connected as is, but it might very well be the problem because maybe the system just isn't capable of addressing the characters. So according to my initial research, there is the lowercase mod, which this seemingly is very, very common, and there's a lot of software that only works correctly if you have the lowercase mod installed. And if you haven't installed the lowercase mod, there's not a lot of software that doesn't run. So I kind of want to make this mod permanent, but I have to find out how this works actually. So after cleaning these little potentiometers here with some contact cleaner, we actually get a stable picture, but it's not what it's supposed to look like, basically. The scrambled screen probably is because we don't have the character mod figured out yet. But yeah, it locks on some video signal at least. We actually, on some positions, we get pretty crisp picture, but then it changes to black and white and color, this rainbow colored stuff again. Yeah, that's pretty promising, even though it doesn't look anything like the system is supposed to look. But I think at least we have most of it figured out. So the video circuitry seems to produce some sort of signal. We have to connect the character ROM back up, or the character generator in this case. At least we got something out of this machine. So several things I've found. Actually, this Z71 should only be these three. So pin 1, pin 3 and pin 5 should be shunted or shorted for the level 2 16K model. And this, which is another array of dip switches, should all be on, which they are for the level 2 mod. Yeah, so without shunting the last one here, facing here, I don't get anything on screen. I get the same lock on the screen, but don't get any output, so I just left it in for now. I'm not exactly sure what it does, but it gives me some kind of output to work by, so yeah, maybe that's correct, or maybe not, I'm not sure. I'm just going to leave it in. And what I want to do now is to reverse or make permanent the lowercase mod, actually. I printed out an old manual for doing the mod, so maybe I'm going to be able to see what we can do to make this permanent, actually. Okay, so my mess of wires that I have in this system seems to be a lowercase mod, but it's not the lowercase mod I just printed out. That actually uses one of the RAM chips, which is located here, Z60. The Z45 mod seems to be a mod that has been done for machines to run the electric pencil word processing software. But at the moment I can't find information about it because the website TRS-80.org is down. I'm not quite sure what this is supposed to switch. I guess you either switch it from here to here or from here to here, but I'm not sure. So, yeah. So while the TRS-80.org website is down, I could download a preview picture from, actually cached by Google probably, from my search, and that's actually enough to determine where my switch should go. That like I suspected, it's a three-way switch connecting either these two or these two, this one and this one, or these two. So you add a switch there, with this being the middle pin. This is the electric pencil modification. I don't know how far it works with other software. Seems to be a much simpler mod than the other modifications I've seen online for lowercase characters. But this seems to be exactly what we had here. And also it added a control key, which came as a kit basically, so you had to cut a trace and solder some wires, and had lowercase characters for the word processor software that this was. And you had a control key that you could, I think, tuck to the keyboard assembly. And that would also explain this weird holes and glue configuration on the keyboard bezel here, which was probably where the extra control key went and the wires to connect to it. Let me see if I can add a switch to the wires there and actually utilize this mod, or at least make the machine work in normal mode or only uppercase characters mode or something like that. Let's see. So it turns out these are not stranded wire, but solid wire, so they are not very flexible. Probably a good idea to replace them with stranded wire at some point. Okay, let's see. Where do we connect what? Okay, let's see if that changed anything at all. Yeah, no. That's not bad, but it's very wobbly. Let's actually switch the switch to the other position and see if that does anything. Oh, okay. At least we get a picture right away. Very much the same. Yeah, not much progress so far. But hey, at least we figured out which kind of mod that is. Considering our sync issues, there was actually a wire installed in this that went to pin 3 of the video output, which isn't actually used. All that is used is pin 4 and pin 5, and then there's another pin, I believe 2, that has plus 5 volts for the opto isolator. But that came from Z5, which is the chip, which is a NAND gate actually, that's used to mix together the composite signal. So maybe there's something wrong there. Okay, look at that. I'm actually measuring Q2 again, the emitter, which should have our video signal or composite signal. And this actually looks much more like a legit video signal to me. Yeah, which actually has some data in it. That looks better now. So probably installing the switch there at least helped with that. So it's not a very good picture compared to this actual thing you see on the scope, but we have like a sync signal and we have the video signals actually in the white level, that is a break in the video signal, the black level, that is the level of the sync, and we have the distance here is the vertical sync. So yeah, that's a composite signal, and this just gets shown as a flickery line on my rather old oscilloscope. But yeah, that should be a legit composite signal, I guess. Okay, so I think I might be onto something regarding the messed up video signal. This is pin 8 on Z6, which should be our horizontal sync signal. And that looks really stable and really nice. It's a bit flickery, but that's alright. That's a good signal still. And we should have on Z57 pin 8, we should have our vertical sync signal. And look at that. That looks really kind of bad. Don't know if that's supposed to look like this. That's a bit wavy. Or the other pins. It looks a bit wavy and shaky. That doesn't look right. Pretty much everything else on this chip is kind of pulsating. Maybe we got a bad Z57. So Z57 or Z57 is down here. And that's a 74C04. I'm putting a question mark in there. It's used to generate the vertical pulse. So that would be an explanation why our video signal was so messed up. Yeah, I'll have to see if I have one in stock, but I don't believe I have. That's an old chip. So it turns out I have a 74LS04 in stock, but this is a 74C04, and that's a completely different chip. So you can replace this with the 74HC04 or with the 74HCT04, I think. So I'm going to order some of those. And yeah, we're going to see if that fixes our problem. This seems to be quite a common issue, actually, that one of these video sync generator or mixer chips dies, actually, and the 74C04 seem to be most prone to failure. That 6, I believe, is another 7404. 74C04, yeah. That's another one. So I'm just going to order a bunch of those. That's going to take some time, so that's going to be part of the next part of this Tandy mission. I'm afraid, because I don't have time to wait for the order to arrive. And the video probably got long enough already. At least we got something. We figured out the mod here. That's not too bad. And yeah, at least found out the issue with the power supply. I also replaced the RAM chips, all of the RAM chips, just to make sure that didn't change anything. And in fact, it didn't change anything. These are new old stock ones, so they should be good. And the fact that it didn't change anything in the behavior might hint in the direction that the original RAM chips were actually good. So yeah, that's where we are. We have a not much working TRS-80 still, but yeah, it's getting better. At least we found a potential culprit for our video syncing issues. What I'm also going to order is an angled pin header to put in here, and then we can just use an IDE cable to connect this. This is 20 pins. The IDE cables have 40 pins, but you can use one row in the connectors, and that allegedly works fine. So yeah, I think that's what I want to do, because I want the keyboard to be kind of detachable. Yeah, so far so good. We fixed some issues. I think that's a wrap for this episode. Here we are. It's actually the next day. I worked pretty late last night on this thing off camera. And yeah, one thing I did, because the scraped traces where this lowercase mod switch connected were not, they were basically disconnecting all the time, and the traces were getting shorter and shorter because parts of it got ripped out by the not very good wires here. And so I connected it to the chips directly, which is, I think it's kind of a better connection now because we get more meat to solder on. I have parts on order to maybe fix this. This is part of my 74 logic stash. I don't have the necessary chips. That at least we figured out that one of our sync chips went out, and also the address line 15 on the Z80 was permanently low, so that could mean that one of the tri-state buffers is broken. I also ordered a replacement part for that. So yeah, there's going to be another part because I have to finish this video and I want to get it out there, and I think there's enough material in the video to be considered an episode of this repair. Hopefully this is going to end up being a repair. I so hope to get this thing running. Yeah, I guess that's it for today. Thank you so much for watching. Thank you for your thumbs and your comments and your subscriptions. And also very, very special thanks to everybody who supports the channel with some money. You're basically making possible that I exist at the moment, not only this channel. So thank you very, very much. And hope you enjoyed this. Hope this was as informative as it was maybe entertaining. Hope to see you all again on this channel. I'm Jan Beta. Thanks for watching. See you next time. Bye.